Okay, hello everyone. In this video, we are going to see the response of the low pass filter and high pass filter for the pulse input. So, in the previous video, we have seen the response of the low pass and high pass filter for the step input. Now, we are going to see the pulse input. So, first of all, what is pulse input? A rectangular pulse will take of constant amplitude V, and this constant amplitude is available for the duration of Tp seconds. Okay, so on the x axis here I have taken the time, and the rectangular pulse is having the amplitude V when time changes from 0 to Tp. And if you observe this particular input clearly, you can able to see two discontinuities. One discontinuity is at t is equal to 0, where the amplitude is changing from 0 to V, and another discontinuity is there at t is equal to Tp, where amplitude changes from V to 0. Okay. So, these are the discontinuities are there, and we know about discontinuities nature for the capacitor and resistor. Resistor will take the discontinuity. Okay. Resistor allows the discontinuities in the voltages or in the currents, but capacitor does not allow sudden changes or the discontinuities in voltage, but it will allow sudden changes in the current. Okay. So, based on this, we are going to see the response of the low pass and high pass filters for this particular input signal. And before going to see actually the operation of this particular concept, one general thing I will give here: whether you are taking low pass or a high pass, that particular circuits are involving series connection of resistor and capacitor. So, like this I am taking, this is resistor R, capacitor C, and here we are going to give the pulse input. Okay. Pulse input we are giving. For this particular pulse input, how these two voltages of the resistor and capacitor will be varying, that is what we are going to analyze now. So, t less than 0, what is the input nature? Okay. So, when t is less than 0, here I am taking input voltage, that is equal to resistor voltage plus capacitor voltage. Okay. So, before t is equal to 0, input is 0, that means I am talking with respect to this area. Okay. So, input is 0. When input is 0, no supply, no current flow, so no voltage drop across the resistor, and if you assume no stored energy available in the capacitor, the initial voltage across the capacitor is also equal to 0. So, that we have to satisfy the KVL at any time, whether it is t less than 0, equal to 0, greater than 0, whatever it may be, at each and every time instant we have to follow, or the circuit must satisfy KVL equation. So, supply voltage is equal to sum of the voltage drops. So, input voltage is 0, resistor voltage 0, capacitor voltage 0, 0 is equal to 0 plus 0. Exactly at t is equal to 0, what is happening? There is a discontinuity in the input where the voltage changes from 0 to 5 volts. And as I said earlier, this change can be taken by the resistor. That means here also 0 to 5 volts change will be there, but capacitor does not allow sudden changes in the voltage. That means whatever the previous voltage is there, same voltage will be maintained by the capacitor. So, if you observe just after the discontinuity, that means t is equal to 0 plus, what is happening? Input is having 5 volts, resistor is having 5 volts, and capacitor will be having 0 volts only. 5 is equal to 5 plus 0, KVL is satisfied. Next, as time is going on, what will happen in the sense, input is 5 volts only, capacitor starts charging because supply voltage is larger than the capacitor voltage. Okay, capacitor can be charged when capacitor voltage is lower than the supply voltage. So, capacitor voltage is 0, but supply voltage is 5. So, capacitor starts charging. So, after 1 second, for example, the capacitor charged up to 1 volt. But in order to satisfy the KVL, here I should keep 4, that means the resistor voltage is reduced to 4. This is similar to our step input concept only. Now, we will assume that Tp is equal to, for example, 3 seconds. Okay, that means input is maintaining V volts for 3 seconds only. That V volts also we will take one value, that is 5 volts. Okay, input is available with 5 volts amplitude. So, at t is equal to 2, input is 5 only, but capacitor is charged up to, for example, 5 volts. Okay, it charged up to 5 volts within 2 seconds only. Okay, and then to satisfy the KVL, resistor voltage must be reduced to 0. Now, at t is equal to 2.9, input is 5 only, because here Tp is equal to 3 seconds we have taken. So, at 2.9, t is equal to 2.9 seconds, V is maintaining as 5 volts. So, input is 5 only, already capacitor is charged up to 5. So, resistor voltage will be 0, and at exactly t is equal to 3 seconds, we have the discontinuity in the input where the voltage falls from 5 to 0. This is the discontinuity we have taken. The discontinuity can be taken by the resistor. How much voltage drop is there in the voltage? 5 volts drop is there. Actually, in the input voltage falls from 5 to 0, but already resistor voltage is 0 only. So, what will happen? 0 to minus 5 volts, this drop will be there. You need to see whether 5 volts drop is available or not. So, input is dropped from 5 to 0. So, resistor voltage must be dropped from 0 to minus 5, here minus is required. Okay. Then what about this capacitor? Capacitor voltage does not change suddenly. Here we have the discontinuity at t is equal to 3. The discontinuity will not affect the capacitor voltage. That means it is 5 is equal to 5 only. Okay. Now, at t is equal to 3 plus, if you observe, input is becoming 0. Okay, input became 0 and resistor voltage is now minus 5 volts, capacitor voltage is 5. Again KVL is satisfied. Okay. Now, if you observe, after t is equal to Tp seconds, or in our example 3 seconds, there is no supply now. Okay, supply became 0, but KVL must be satisfied. Now, within the circuit, how the circuit will be available means resistor is there, capacitor is there, and source is ceased to 0. Now, there is no input, input is equal to 0, voltage source is 0 means short circuit, but across the capacitor we have 5 volts, okay, and across this particular resistor we have minus 5 volts. So, in the circuit, now the capacitor is acting as a source, capacitor starts giving the voltage to resistor, capacitor starts discharging, okay. Up to Tp seconds, capacitor has been charged, when the supply voltage is lesser than the capacitor voltage, or in this case supply voltage became 0, so capacitor will be discharged. So, capacitor starts giving the energy to the resistor, it is giving the energy means it is losing the energy. For example, it became 4 volts. So, that in order to satisfy the KVL, the resistor voltage must be minus 4 volts. Like that, as time is going on, what will happen? Completely the capacitor will give the energy to the resistor. So, resistor voltage will be increasing to 0. So, this is what we have to observe before going to see the response of the low pass and high pass for the pulse input. Now, you can able to check how the resistor voltage is changing, how the capacitor voltage is changing. How the capacitor voltage is changing? It is increasing from 0 to 5, then decreasing to 0. So, if you draw the graph for the capacitor voltage, it is increasing up to 5, then decreasing to 0. What about resistor voltage? Resistor voltage from 5 volts it became 0, then sudden change is there up to minus 5 volts, then increasing up to 0. What about input? Input from 0 to Tp seconds, it is maintaining 5 volts, then becoming 0. This is input, that is equal to resistor voltage plus capacitor voltage, this is a KVL. Now, if you take output across the capacitor, that is the low pass filter output, this is actually low pass filter output. If you take output across the resistor, that is nothing but high pass filter output for the pulse input. Okay. So, we will see in detail. Okay, equations also we are going to give for the response of the low pass and high pass circuit.